Hello, am I audible? Gaurav?
Yes, probably.
Hi, how are you?
I'm good. How are you?
Fine also. How are things?
It's going good.
Going good. About the assignment, last assignment?
Yeah, his last assignment was also good. Okay.
Okay. Any problem you
Yeah.
faced?
No, drawing solving, I didn't face any problem.
Okay.
Yeah.
So let's start today's class. I welcome you all to this NPTEL FEM class for the discussion session for the January to April 2025 batch. So this is week number 9. My name is Nikhil Gupta. I am the research scholar in Department of Civil Engineering, ISC Bangalore. So let's start solving the questions which are given in the assignment number 8. So this is the first question. Consider the following linear isoparametric mapping from parent domain to physical domain. Location of the quadrilateral in physical domain is shown below. Now answer the following question 1 to 4 based on the isoparametric mapping. So the question says, with the help of isoparametric mapping, x and y can be written in which form of the parametric form? So same question I have done in the previous class also. The coordinate system coordinates are changed. So let's start solving the question. So we know for in the value of shape functions are given like this. We have already seen in all questions. Now we know the shape functions directly, so we can write it. So these are the shape functions. Now we'll start solving the problem. The coordinates are given here. I'll write the coordinates as well. x1 is 1, x2 is 3, x3 is 3, x4 is 1. Similarly, y1 is 1, y2 is 1, y3 is 2, and y4 is 2. These coordinate systems are written on the basis of this physical system. So we have to write x in terms of xi and neta. So we know x will be the summation of I equal to 1 to 4 ni xi. So we can write here n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. When we substitute the value of all n's, we can take out 1 by 4 common outside, and we can write the other terms like this: 1 minus I, 1 minus neta into 1, which is x1. Then n2 is 1 plus xi, 1 minus neta into 3 plus 1 plus xi, 1 plus neta into 3 plus 1 minus xi, 1 plus neta into 1. So when we solve this, what we'll get 1 minus neta minus xi plus xi neta, then 3 minus 3 neta plus 3 xi minus 3 xi neta plus 3 plus theta 3 neta plus 3 xi plus 3 xi neta plus 1 plus neta minus xi neta. Okay, so what we can see, what are things which are cutting? This neta can be cut by this neta, then 3 neta cut down. This is 3 sin eta, 3 sin eta is cut down. Then this sin eta is gone. That's it. Now what we can write? We can write 1 by 4. The constant term is 1, 3, 4, 6, 7, 8, 9. Oh, 1, 3, 4, 6, 7, 8, and this one is also there. 3, 4 and 4, 8. Okay, correct. Then plus xi term will be minus this 2, then 7, and this will be 4 xi. Correct. 3, then 2 and 2 here. Okay, 4 xi. So we can write it as 2 plus xi. Similarly, we can do it for y as well. So while writing y, we can make 1 by 4 out, and we can write accordingly y1 and y2. This will be 1 plus 1 plus xi, 1 minus neta into 1 plus 1 plus xi, 1 plus neta into 2 plus 1 minus xi, 1 plus neta into 2. So when you solve this, what you will get? 1 by 4 of 1 minus neta minus xi plus xi neta plus 1 minus neta plus xi minus xi neta plus 2 neta plus 2 xi plus 2 xi neta plus 2 plus twice of neta minus 2 xi minus 2 xi neta. So when you cut the terms, then this 2 neta will be cut by this 2 netas, then this xi is cut by this is cut by this, then anything else, I think 2 xi neta is cut by this and 2 zeta is cut by this. So when you write, simplify it, you will get 1 by 4, 6 plus 2 neta. So if you check the solution, okay, so it's 3 into 0.5, so we can write it as 0.5 outside, and we can write 3 plus neta. So this is y and this is x, 2 plus xi. So if you see, the solution is B. So the other question is, what will be the determinant of Jacobian J? So we all know what Jacobian is. It is del x by del z, del x by del neta, del y by del xi, and del y by del neta. Okay, so we have calculated x and y in the last question. So x is this and y is 0.53 plus neta. Now we can calculate the terms which are present in the Jacobian. So it's del x by del xi equals to 1, del x by del neta equals to 0, del y by del psi equals to 0, and del y by del neta equals to 0.5. I hope this is clear. Now we'll put the values. This will be 1, 0, 0 and 0.5. So when you find the determinant, you will get 0.5. So answer is A. Now the third question. Okay, suppose we have integration in physical domain over the quadrilateral and we want to transfer the integration to parent domain to carry out the numerical integration. What will be the form of integration in parent domain? I is given like this. So it's simple question. I have solved it earlier also. I is given like this: x square y square dx dy. Now we have calculated x 2 plus xi and y is 0.53 plus meter. So here we can write dx equals to d xi and dy equals to zero point 0.5 d meter. So we can substitute x and value in the main integration problem, and what we'll get? We'll get 2 plus xi whole square and 0.53 plus neta whole square with d xi and zero point 0.5 d neta. Okay, so what we can see? We can see 3.5s are there, means 2 from here, 1 from here. So what we'll get? We can write 1 by 8 outside, and we can put since there are two integration, we can put two ways as this, and this will be 2 plus xi whole square and 3 plus neta whole square d xi and d neta. I think this is the form which is given in the answer. So if you see, the answer is I think D part. Yes, sir. The answer, yes, the answer is D part. So the other question is that suppose we want to carry the integration using the 1 point Gauss quadrature. What will be the value of integration? Okay, this is also the simple version. So in 1 point problem, 1 point Gauss quadrature, we know weight is equal to 1 and that sampling point is 0. So since it is 1 point Gauss quadrature, what we'll get? We'll get the solution as I is equal to W1 phi 1. So W1 is 1 and phi 1 is value of that function at sampling point. So let's calculate that first. So phi 1 equals to x square y square at 0 0. So which will be no, wait. So it will be this we are solving the integration. So I is 1 by 8, then integration -1 to 1 -1 to 1 2 plus I whole square plus 3 plus neta whole square d xi d neta. Now what we can write? We can write this at 0 0. So this will be 2 plus 0 whole square and 3 plus 0 whole square. So this is 1 by 8 into 4 into 9. So you will get here 1 2 and 4.5. So answer is C part. So let's start with the question number 5 now. Okay, so consider a two-dimensional rectangular domain 2 cross 4 meter square subjected to heat flux, and we are solving Poisson's equation. Boundary condition of the domain is shown in the figure below. The domain is discretized with two numbers of triangular element and degrees of freedom are shown. Okay, so 1 2 3 are there, one element, and second element is 1 3 4. So solve the domain to find the temperature of node 2 and node 3. Answer the following question. Okay, so the fifth question is stiffness matrix can be written like this. Yes, we know all this. B is the temperature gradient relationship and B is the matrix of element number 2. Consider order of degree of freedom 1 3 4. So 1 3 4, this element we have to take and we have to solve it. Okay, so let's start solving. So 1 3 4, so we'll write the coordinates. which will be node 1 is 0 comma 0, node 2 is not node 2, node 3 will be, because we are talking about the element 2. This will be element node 3, and it will be 2 comma 2. No, not 2 comma 2, it should be 4 comma 2. Wait. It should be 4 comma 2. Yes, it is 4 comma 2. So node 3 is 4 comma 2. Node 4 is 0 comma 2. Okay, so what I'll do, I'll solve the both the elements together, then we'll see, and we'll get the K matrix, because I think we need a K matrix here as well. So let's start solving. So the area will be 1 by 2, 4 into 2, which will be 4. Okay, then n1 we can, ni we can write 4 upon 2a, ai bix plus ciy. Now we have to calculate the bi and cii. So what we can do, we can write bi as yi, yj minus yk, this all we know. Then we'll calculate b1 as, it will be 0 minus 2, which is minus 2. b2 will be 2 minus 0, 2, and b3 will be 0. So how this is calculated? Okay, so I am taking element 1 here, 1. So this is the element 1, and the coordinates are 0 0. Second is 4 comma 0, and third is 4 comma 2. So for b1, which is this will be yj, means 0 minus 2, which is minus 2. For b2, which is this will be 2 minus 0, so 2. For b3 it will be 0 minus 0, so 0. Similarly, we can calculate ci also for this, which will be xk minus xj. So c1 will be 0, c2 will be 0 minus 4, which is minus 4, and c3 will be 4 minus 0, so 4. How this is calculated? For c1, we go here. So for c1, we want xk, means 4, 4 minus 4, so c1 will be 0. For c2, here we want x, means 0, and minus 4, so minus 4. For c3, it will be 4 minus 0, so 4. Now we'll put the value in the n function. Since we want the dn, so we can differentiate dn1 by dx. What we'll get, we can remove this ai term, and we can get 2a into bi for x1. So we can directly put the values there. So for dn1 by dx, it will be 1 by 8 into minus 2, which is minus 1 by 4. Del n2 by del x is 1 by 8 into 2, which is 1 by 4. Then del n3 by del x is also 1/8 by 8 into 0, so which is 0. And del n4, oh, del n4 is not required, I think. Del n4 is not there. Okay, so when we make this matrix, we will get the B matrix will get minus 1 by 4, 1 by 4, 0, and 0, minus 1 by 2, and 1 by 2. We can take 1 by 4 out. So B for element 1, will be minus 1, 1, 0, 0, minus 2 and 2. Okay. So, okay. Since we have B matrix, we can get the K matrix for element 1 as well, which will be B transpose B. So, this we can do. So, K matrix will be minus 1, 1, 0, 0, minus 2, 2, and minus 1, 1, 0, 0, minus 2, 2, with 1 by, what will be there, 4 for 16 it will be there. So when you solve this, you will get 1 by 16, 1, minus 1, 0, minus 1, 5, minus 4, 0, minus 4, 4. So accordingly we can write this is 1, 2, 3 nodes, 1, 2, 3 nodes. Similarly, we have to solve for element 2 as well.
One out here, sir.
What?
The C term also has to be multiplied, no? The
C term?
While finding the stiffness matrix, it should be B transpose into C into B.
I missed to calculate.
Multiplied by the area also.
This we have to calculate as well. Del n1 by del y, del n2 by del y, del n3 by del y you have to calculate. So that's why this term will come. So when you solve this, you will get.
No. That is okay. And what I'm saying is, while finding the stiffness matrix, we have to integrate in the domain for B transpose into C into B.
C, yes. That will be. That will be, I think, K by something, na?
Mine came 3 by 8.
It will be 3 by 8 where I have done it. Actually I was multiplying. K by 2a. Is it like that?
C by 2a. K.
It will come by like this, na?
Yes.
K. So because 2a is there. K is the flux, I think it is given. K is this. This is given here.
Yes, 6
so
is
you
given.
have to multiply that as well.
Yeah, 6 has to be multiplied.
6 has to multiply. But since I was doing for one element, so 6 directly we can multiply here. Okay.
Area also has to be multiplied, no?
6 by 2, na?
No, area.
Area is 6 by 2a. So 2 into 8. Correct now?
No. What you did was B transpose into B, right?
Yes. So it is B transpose C B
into dx dy.
Into dx dy. So I did B transpose B.
Yes. So C and area has to be multiplied.
Oh. C and area. So C we write as it as.
C is a scalar only because it's an identity matrix.
So what we know, I know is C is equal to K by 2a.
No, C is only K, no?
C is only K, then 2a we need to multiply it.
Yeah, and area only means not 2a. dx dy is a only, no?
This is, you said dx, so okay. So you are saying B transpose B K into area.
Done. Yeah. K into area part is missing, no, in your integration.
And this is missing. Actually, I was solving yesterday. I didn't get the correct answer for this. I think this is the one what I was missing. Okay. So did you get the correct answer for this question?
I think so. Yes, I was having some trouble, but.
So I think the answer is A part, which is they have given. A or C they have given. I didn't get the correct answer for this, so I can skip. I want to skip this question. Maybe this is the problem.
Because in the question also it's written. I think the definition of matrix is given.
Or dx dy is given. But dx dy
So
will be used for integration, no? Dx dy we can use at area.
yeah, because B transpose in C into B,
C into B.
this will give this doesn't need to be integrated
Yes, yes.
because it's a scalar term
Scalar
only.
term. C
So
also
this
K.
can come out of the integration, but integration of dx dy over the domains would be the elemental area only.
Okay. Correct. So I'll leave this question.
What you have done is B transpose into B.
B transpose into
So
B,
extra
then
term C into A has to be
K
added
into
because
A
both
should be
are scalar
multiplied.
only. Yeah. Yes. So only the constant term will get affected.
Yes, correct.
Out of the matrix.
So similarly, you will make for element 2 and make it a global matrix. And when you will do, you will get here 5 minus 4 and 5. Okay. So okay. Then you will directly solve. You can solve and get this question number 7 solution as well. Okay. Question number 8 we'll see. Consider a two-dimensional domain which is discretized with triangular elements as shown below. The domain is subjected to Qn and its boundary and the elements are shown inside the circle. Okay. Identify the incorrect option corresponding to boundary integral and find QE for the domain. Okay. Okay, we don't have to find anything. We have to just it's a theoretical question. Okay. So the first part is saying boundary integral is required for element A. It is required. It is there. So as one of the sides of the element, so this is correct. We have to get the incorrect one. This is right. Boundary integral is required for element 2. It is required. Okay. Boundary integral is not required for element 6. Not required because it is not connected to boundary. This is also correct. And it is saying boundary integral is required for element number 3 as one of the node of the element it coincides. No, this is not correct. We don't need a boundary integral for this as well. So this is the D option. Consider the triangular element is subjected to constant flux Q naught to its one of the side AB. What will be the element flux vector QE of the element? Degree of freedoms are in ascending order. Okay, I don't have solution for this as well. I don't have the solution for this as well, but I think that can be done easily. So I'll leave this question as well. Also, I don't have the solution for this right now.
Yeah, I think this can be solved using the Lagrangian functions.
Means you have to find the force vector, no? Flux vector.
The question is asking the force that will be at 1, 4 and 2.
All they are what, no? 1, 2, 3, 4, 5, 6.
Yeah. So basically, only the force will come at 1, 4 and 2.
1, 4 and 2. Sure. So they want to distribute the UDL on the nodes.
Yes.
So I've discussed such questions.
And one, it was a parabolic variation of
it
for
was
the
N
line
transpose Q dx. It was something like this, no? Okay.
N1 was like 1 minus x bar by h into 1 minus 2x by h. That we can use.
We can use there. Okay, no problem. So consider the higher order triangular element which is subjected to a boundary flux to one of its side. Nodes of the elements are shown in red dot. Boundary flux varies nth order. What will be the order of polynomial? So it can be captured exactly. So I think the question, this question has given answer as C. Is it?
Yeah, it's given C.
But I think if the question is this, the answer will be 2.
Yes, I had put 2 only, but it got...
No, actually the diagram is missing here. For the answer they have given. For the answer they have given, they have put 2 here. So that will be 3. So that is missing here. But according to this question, and if you are referring to this figure, the answer will be 2.
Referring to that figure only, I put
because question, it's not there. So when I was solving yesterday, I saw that the figure is missing there. But if you are referring to this figure, the answer will be 2.
I don't know. So this will be marks is deducted for this.
Means they have some problem in their answers. I don't know how will they rectify. Every time they have this problem.
Yes, yes.
Okay, so let's start the questions related to week number 9. This is a little big question. So it says, suppose there is a body of thickness h. It is made of an isotropic material, and the governing differential equations are given. So can you tell me which equation is this?
Yes.
So this is the basic equation. It has a well-deserved name. So this is a solid
I've
mechanics.
seen somewhere in like my advanced solid mechanics
Yes.
classes.
It is solid
I don't
mechanics.
remember right now.
So it's a equilibrium equation.
Yeah.
It's
But
equilibrium.
body force would also be there, no?
Body force generally they can take 0. So total equation what it is rho b equals to
Plus
rho u dot dot. So this is acceleration. It means basically initial term we take 0, and sometimes we take body force also 0. So it directly becomes delta sigma 0. Okay. So
yes.
these all are usual meanings. So what it is saying, the question, you have to form the weak form of it. Means where the question is the weak form of the corresponding 2D elasticity case will be. So you have to get the weak form of this 2D elasticity problem. So let's start solving the question. So it is given del dot sigma is equal to 0. So for forming the weak form, we know we have to multiply it with weight function. But before that, let's simplify this equation. So when we'll simplify this equation, we'll get del sigma xx del x plus del sigma xy del y equals to 0, and del sigma xy del x plus del sigma yy del x. Oh, something is wrong. This will be x here, this will be y here. Okay. Correct. So since we see there are two equations, we have to use two weight functions here. So let's multiply the first equation with weight function. Del sigma xy del y to dv equals to 0. Okay. So when we'll solve this, we can see we can break it into two. W1 del sigma xx by del x dv plus, or we can write, since it is 2D elasticity, we can write dx dy with h as the thickness, and here also we can write, so here it will become some omega only, and this will be w1 del sigma xy del y dx dy. So to solve this, we can take this as I1, this as I2, and let's start with I1. So this is the term, this we can represent it as del by del x of w1 sigma xx minus sigma xx del w1 by del x. This is nothing but just the multiplication rule. I'm writing in a reverse order so that we can replace this term. So what I1 can be written it as, can be written as del by del x w1 sigma xx minus sigma xx del w1 by del x dx dy. Now to solve this, we can use a Gauss divergence theorem. So with that we can represent it as surface integral of W1 sigma xx nx ds. So this is a Gauss divergence theorem to convert the volume integral to surface integral. Now we can write full I1 as surface integral of del by not del, it will be W1 sigma xx nx ds minus volume integral of sigma xx del W1 by del x dx dy. So this is the all the term which was coming already here. Okay, so this is the first, and similarly if you solve I2, same result you will get. Means this is the I2. So xy, not the I2, you will include this as well in the, I think this is the answer is given like this only. Okay, so this is directly you can add in this sigma xx minus w, and okay, so I2 if you see you can write directly here. So this will multiply with h as well. Something is missing again. Sigma. Okay, no, this is done. Okay, this I have included here. Now I2 I can write in the similar way. W2 sigma xy ny ds minus volumetric sigma xy yy or sigma yy. Something missing or what? Doing something wrong again. Okay, I1 is correct, but this is the I1. So first write I2. I2 is W1 del sigma xy of del y dx dy. Okay, so when you solve this you will get integration of W1 sigma xy and y ds minus volumetric of sigma xy del W1 by del y dx dy. Now okay, now you can add full I. I'm adding the I1 and I2. So what you will get? You will get integration of minus sigma xx del W1 by del x minus sigma xy del W1 by del y dx dy plus surface integral of W1 sigma xx nx plus sigma xy and y ds equals to 0. Also h will be included in all the terms, so I can directly write h multiplied by this full. Okay, so we all know one identity in form of sigma xx equals to lambda plus 2 mu epsilon or with del u by del x plus lambda times dv by dx dy. This is the basic equation of the stress into displacement with the Lem's constant, and the sigma xy equals to sigma xy is, see the equation, this is the equation. Sigma yy can be written as lambda of del u by del x plus lambda plus 2 mu del v by del y, and sigma xy is can be written out 2 mu of half del u by del y plus del u by del x, which will equal to mu of del u by del y plus del u by del x. So we'll substitute this and we'll get the solution as h of lambda plus 2 mu del u by del x plus lambda of del v by del y dw1 by dx plus mu times del u by del y plus del v by del x dw1 by del y to dx dy integration. So if you see one of the equation we have solved it, and the answer will be B part. It's the same way you can solve for I2 as well, W2 also, by multiplying here with this, and you will get the second equation also with this. So this this little advanced solid mechanics course. You have to brush up your thoughts about that, and then you can get it now. Okay, let's solve the question number 2. So it says, suppose a 2D elasticity body as shown in figure 1 was in temperature of 20 degrees Celsius. Suddenly the temperature of the body is reached 150 degree. Coefficient of thermal Young's modulus and Poisson ratio are given. Thickness of plate is given. Now body is discretized into two CST element as shown. And this node shape functions are given here. And we have to, what we have to do, we have to do a we have to find the B of element number 1. You want to read one time the question? I'll stop for 2 minutes to get to the question if you want to.
Yeah, right.
Okay, so let's start solving it. I think the options are here. Okay, so B element, we know it is 2 of EF element, beta 1 0, beta 2 0, beta 3 0, then 0, gamma 1 0, gamma 2 0, gamma 3. This is gamma 1, beta 1, gamma 2, beta 2, and gamma 3, beta 3.
I have one question here.
Yeah, tell me.
How do we write this matrix? This means the 0 which we are introducing.
Here, this
is as per the degree of freedom of the element.
Yeah, as per the degree of freedom. You are right.
There is 6 degree of freedom, so we are.
No, actually, this is epsilon into B into something, na? B into del matrix. Delta. So accordingly, you have to multiply with this beta to this. Other term should be this, and so since epsilon xy is there, so both terms will be there. This is epsilon xx. So in epsilon xx, y terms will not be there. So we have made it as 0. For epsilon yy, this x terms will be 0, and this gamma 1, gamma 2, gamma 3 will be there. For epsilon xy, we take both the terms, del u by del x and del v by del y and del x.
Okay.
So it is related to that. That's why we keep it like this.
Okay, understood.
So we have to find the value for element 1, which is like this. This is 1, 0, 0. 2 is 200, 0. And 3 is 0, 400. So beta I is given as yj minus yk. So beta 1 is 0 minus 400. So minus 400. Beta 2 is 400 minus 0. so 400. Beta 3 is 0 minus 0. And gamma I, we know it is xj minus xk. So gamma 1 is minus 200 minus 0, which is minus 200. And gamma 2 equals to 0. 0, so it will become 0. Then gamma 3 is minus of 0 minus 200, so it is 200. And if you calculate the area, we need 2a, so I will calculate 2e only. So 2 of 1 by 2, 200 into 400, this will give you 18. Now we'll put the value in the b element. We'll get 1 minus 200, 0, 1 by 200, 0, 0, 0, 0 minus 1 by 400, 0, 0, 0, 1 divided by 400, minus 1 divided by 400, minus 1 divided by 200, then 0, 1 by 200, 1 by 400, and 0. So this is the B matrix. You'll see the answer is D part. Just the simple mathematics in this question. So this question number 3 we'll see. Now this is also easy. Consider the plane stress condition. Elemental force vector can be expressed like this. So since they have given the vector only, so we just have to put the values in it. So the vector is given as et alpha t 2 1 minus nu, then beta 1 gamma 1, beta 2 gamma 2, beta 3 gamma 3. So the given values I'll write directly. It's 70 GPa. Nu is given as 0.3. Temperature which is changing to 150 from 20, so it will become 130 degrees Celsius. Thickness is given as 0.2 mm, and alpha is given as 1 into 10 power minus 6 per degree Celsius. So we have to calculate. We'll get the same beta values as previous, since the element is same. So we can repeat that values. Gamma 1 is minus 200, gamma 2 was 0, and gamma 3 was 200. So we'll just put the values in this matrix. We'll get minus 520, minus 260, 520, 0, 0, and 260. That will Newton. So if you see, the answer is C. What is the thermal vector for element 2? Now since we have done it for element 1, we have to do it for element 2 as well. So element 2 is this, I think the next question. Okay, so this is 2, 3, 4. So the coordinates are given as 200, 0. This is 200, 400, and fourth is 0, 400. So now since we have calculated for element 1, now we have to calculate for element 2 the beta values. So beta I is yj minus yk. Beta 1 will be 400 minus 400, which is 0. Beta 2 will be 400 minus 0, so 400. Beta 3 will be 0 minus 400, this is minus 400. Simply will calculate gamma values also. So the formula is minus xj minus xk. Gamma 1 will be minus 200 minus 0, so it is minus 200. Gamma 2 is equal to minus of 0 minus 200, so it will be 200. Gamma 3 will be minus of 200 minus 200, so it's 0. So we'll put the value in the vector of element 2. you'll get 0, minus 260, 520, 260, minus 520 and 0 Newton. So answer is D. Now what they are asking to get the global thermal vector, which I have calculated for both the members. So first I'll write the answer, then we'll match up what it is given. So it's minus 520 minus 260. F of element 1 is minus 520 minus 260, 520 0 0 250, 520 0 0 260. This is for element 1. For element 2 it is 0, minus 260, 520, 260, minus 520 and 0. So the nodes which are related to this are, for element 1 it is oh no, element 1 I'll check, it's 1 2 3. So this is 1, this is 1x, 1y, 2x, 2y, 3x, 3y. Oh, sorry, this is not this. This is 1x, 1y, 2x, 2y, 3x, 3y. Similarly, for this is 2, 3, 4. So there will be 2x, 2y, 3x, 3y, 4x, 4y. So when you will make the global matrix, you will need 1x, 1y, 2x, 2y, 3x, 3y and 4x, 4y. So what it will come? 1x you will get from F1, which is this minus 520. Then 1y is here only, so minus 260. 2x you are getting from both, but this is 520, this is 0, so this will be 520. And 2y here 0, here minus 260. 3x what you are getting, 3x you are getting 0 from here, and 520 from here, so that will be 520. 3y 260 here and 260 here, so it will 3y is 260 here, and 1x 1y 2x 2y 3x 3y 2x 4x 4y minus 520 4y. I think something I mentioned it wrong. F1 checking, let me check, it's 0 0 260. So 0 0 260 is there. Then 3x 3y 3x 3y 3y is 260, 260 will become 520 3y, but the answer is saying 260. Did I make a mistake here? Let me check. It is 0 2 minus 260 520 260 minus 520 0, it is correct. And F1 is minus 520 minus 260 520 0 0 260. Then what is the problem? Okay, should not create a problem then. Minus 520 minus 260 is correct. 520 minus 260 is also okay. Then 3x is 520. 3y 260 is here. Okay, let's write 520 again, but there is no option like that. I think I did a mistake somewhere. 260 and 4x is minus 520, and this is should be 4y, 3x 3y. The first is 1 2 3. Let me check the question. Oh, this is 1 2 4, and this is 2 3 4. Okay, sorry. So this is fourth actually in the global coordinate system. So this will be 4x 4y, and this will be 4x 4y. Okay, so 3x will be 520, 3y will be 260, then 4x is minus 520, and this is 260. Is it correct? Is it okay with you, or you get confused?
No, it's okay. There was a mismatch in numbering.
So I'll write the final answer. Minus 520 minus 260, 520 minus 260, 520, 260 minus 520 and 260. So the answer is A part. Okay, question number 6. Okay, so they are saying that what will be the reduced matrix. Okay, after putting the equation, that boundary condition, let's open the main question and see the. Okay, so this two are given. So u4 is known, 3 is known, 2 is known, only 1 is missing. Or okay, so u1 u2 are the two which are unknowns. So u1 and u2, you see only D option is there, so we can directly write, and let's suggest k11, k12, k12, k22, u1, u2, and simply it will be f1 and f2. So answer is D. Now let's go to question number 7. Okay, so it says, suppose a 2D isotropic elastic body was in temperature of 30 degrees Celsius. The temperature is increased to 300 degrees Celsius. Coefficient is given, Young's modulus is given, Poisson ratio is given. You have to get the longitudinal component of thermal strain considering plane strain condition. Okay, so since temperature is increased to 300 from 30 degree, so it will be 270 degrees Celsius. Alpha is given as 1 into 10 to the minus 5 per degree Celsius, and nu is given as 0.29. So we have seen for the plane strain condition, sigma yy and sigma xy is given as 1 plus nu alpha t and 0, and you solve this. It's just the putting the value in the formula, so it will be 3.48 into 10 to the minus 3, 3.48 into 10 to the minus 3, and 0. So top one is the longitudinal strain, so this will be 3.4 into 10 to the minus 3. Okay, so let's go to question number 8 now. 8 is directly the they are asking, write the Lagrangian polynomial for 5. So this I have already discussed in class, that it is x minus x naught, x minus x1, x minus x2, x minus x3 till x minus x5 divided by x3 minus x, x3 minus x1 till x3 minus x5. So you can match the answer for this. So I think the answer is B part. X minus, no, this is correct. Down is correct. What about this 2? No, this is missing. The answer is B part. Okay, so last question for today I have kept like this. So It is saying solve the Poisson's equation, which is given is this, in a square whose vertices are 0 0 1 0 1 1 and 0 1, which is shown here. We have to use a 4 triangular elements in the upper half of triangle, which is this, because of symmetry, and we have to solve the question. So few things are given here. So let's start solving the question. So the Poisson's equation is minus of del 2u by del x square plus del 2u by del y square is equal to q. Simplified way we can write this at like this also. So k of the element which is given is half of alpha plus beta minus alpha minus beta minus alpha alpha 0 minus beta 0 beta. Okay, so if you see the question and the coordinate like this, we can write alpha beta, let's say this 1 2 3, and this is a, this is b. So alpha will be b by a, beta will be a by b, and f which is given, it is given as qab by 6 1 1 1. So we can calculate all this. Now we can apply this in our question, which is given like this. So this is 1 2 3 4 5 6. The coordinate is 1 comma 1. This is 1 comma 0. This is 0 comma 0, and this is 0 comma 1. So ux1, two boundary conditions are given, ux comma 1 and u1 comma y. When you combine this, you can get to know that, you see, x comma 1, x comma 1 means y is equal to 1, means this is here, and uy 1 comma y, 1 comma y means x is equal to 1, x is equal to 1 is this. So since we are using the top symmetric only, we can say u4 is equal to u5 is equal to u6 is equal to 0. Now we have to write the kd is equal to f, solve it. So the u vector means d vector will be u1 u2 till u6 transpose, and in all four elements you see the value will be same. So all four elements, a is equal to b is equal to 0.5, just the calculation. So alpha and beta will be 1. Now, and we'll put the k element values of alpha beta. We'll get half of 2 minus 1 minus 1 minus 1 1 0 minus 1 0 0 0 and 1. Just I have put the alpha beta values for all the means just the value in that. So we'll some simplify it, we'll get this as this. So this belongs to 1, this belongs to 2, this belongs to 3. 1 2 3 nodes. Okay, so let's discretize the domain. It is like this. So let's take this as first, let's take this as 2, this as 3, and this as 4. So node numbers are given like this. Okay, so we have to write this equation for each of the node elements, and we have to make a global stiffness matrix. We have to see which all node numbers are matching in this equations. It's better that our k elemental matrix is same for all, so we can utilize it, and when we'll make the global stiffness matrix, we'll get 0.5 minus 0.5 0 0 0 0, then minus 0.5 2 minus 1 minus 0.5 0 0 0 minus 1 2 0 minus 1 0, then 0 minus 0.5 0 1 minus 0.5 0 0 0 minus 1 minus 0.5 2 minus 0.5 0 0 0 0 minus 0.5 and 0.5. Whenever you make a K matrix, global state matrix, do check that it is symmetric. So if you see 1 2 3 4 5 6, similarly 1 2 3 4 5 6, all nodes we have defined it, and we can solve it further. So what they have asked in the question, so we have to solve this equation. Okay, so we'll similarly f vector also we can write, which is given as QAB by 6 1 1 1. So this will be 12, which is given 0.5 by 6 1 1 1, and this will come out to be 0.5 0.5 0.5. F factor now we have, so force matrix will form. This will give you 0.5 1.5 1.5 0.5 plus R4, then 1.5 plus R5, and 0.5 plus R6. So this is the global step, the force matrix. When you get this, what you have to do, you have to make a K global, U global, and F global, and you have to remove the lines or the known degree of freedoms and solve it for the unknowns, and then you have to replace it with the known, then you have to get the known unknown forces also. So today's class I have only this much. It was a little fast class, I believe, but I hope you have got it something.
Yeah, thank you.
Means it was a fast class.
Yeah.
So you see the videos.
Yes.
I know I also got some confused in some questions. So I ran it again. So
yeah, I got the idea, but
you got the idea, na?
Yes.
Okay.
Okay, thank you.
Thank you.
Yeah, bye.
Bye.